Good morning, everyone. Thank you for joining us today. My name is Kim Meijer. I'm with the AIMS marketing team, and I will be your host during today's webinar. I'd like to welcome you today to our webcast about improving your performance in the Hinterland. Before we get started, I will cover a few housekeeping details, and then I will introduce our agenda and give some short background information about our partnership with AppOvo. Your phone lines will be muted during the presentation, so please use the chat function in the GoToMeeting control panel to communicate with me or the presenter throughout the presentation. At the end of the presentation, we'll take as many questions as time allows, so you can submit your questions using the Q&A tab in the control panel during the presentation, or you can save them for the end. Today's webinar will be about 45 minutes long, and a recording of the webcast will be emailed to you, so if you miss something, you can always view it again later. So who are we? AppOvo and AIMS are partners since 2004, and starting out as a provider of consultancy and product management services, AppOvo is now also a provider of advanced planning solutions for a broad range of logistic processes and uses AIMS of one of their technologies for the foundation of this. The solutions are applied in several sectors, ranging from retail to deep sea tonnage allocation, making AppOvo a key player in the field of transportation and logistics. At AIMS, we continuously work to provide a platform for partners like AppOvo to develop and deploy custom apps, and we try to do this in a fast way, and we provide secure web-based solutions. What will we cover today? To have a successful transportation plan, good insights into the dynamics of the environment and possibilities related to your business are required. Therefore, we will offer you to look at new possibilities and current challenges in the dynamics of the Hinterland, followed by how to apply big data in a successful way. Last, we will show how decision support enables your company to improve performance by presenting a customer case and a live demo. In the customer case, we will show how to standardize and simplify the planning of multiple transportation models. And in the smart barging demo, we will show a scenario analysis how to design the most optimal network for tonnage allocation. With that, it's my pleasure today to welcome our presenters, Walter and Art-Jan. Walter Kusters is the Business Unit Director and Consultancy at AppOvo, and he has been working there for more than 5 years. The strong background in the Hinterland makes Walter successful in enriching business models with big data. Art-Jan is a senior consultant at AppOvo and has been working there also for a long time, for more than 10 years. His direct involvement in the collaboration with different key players in the Hinterland gives Art-Jan excellent knowledge about smart capacity planning. So with that all said, I'd like to turn the presentation over to Walter.
Yeah, good morning everyone. I first want to explain shortly how the Hinterland works. I mean, most participants are familiar with the Hinterland, but it's good to realize the complexity. As we all know, there are a lot of execution partners involved in the Hinterland. Despite it just looks like a container transport, but next to the deep sea carrier, the deep sea terminal, and the barge or rail operator is involved, inland terminals, trucking, and of course the shipper and some customs rules. So, and all these actors have their own planning and their own challenges, which makes communication and optimization quite difficult. It's not only as showed in the green buttons, but also in the yellow ones, where there are internal choices to make. How will I execute my Hinterland transport? Which deep sea carrier will I choose? And for what price I will sell my products to the involved shippers. And when you have made these choices, you have also the effect of external factors. Because many times carriers arrive a bit later in the port, it can be just a few hours, but resulting in a later shift of the deep sea terminal. It can be that a barge is cancelled or other reasons that makes planning difficult to have a reliable execution. So when we look into a bit more detail, we see that in this hinterland chain a lot of information is available. It's a tremendous number of data, and all execution partners are registering this data, and they do it all in their own way, and they're also using the port community systems in place like Hamburg, Rotterdam and Antwerp have. And if you look to these systems, both own systems and the port community systems, the data is relatively easy to get and to use. But in practice, you see that not much companies really use all this external data. There is some good exchange of data between execution partners connected to each other, but there is no integral information exchange, and port community systems are mainly used to follow the official procedures instructed by the government, and the port community systems are not used for commercial exchange of information. And yeah, when we look at that, we have the feeling that most companies stick to using their internal data because in practice they don't have enough time to take a better decision, because when a container is delayed in the port of Rotterdam, the shipper is already shouting that he wants it now. So then he decided to go for trucking, or the barge operator is already happy that he serves all the terminals in Rotterdam and is wondering where he will have a delay. So instead of having an integral look and looking at the possibilities using external data, they face only their own internal data and try to survive. A second problem is that they don't, if you have the data, it's difficult to oversee the integral complexity, because if you take everything in account, it's quite a complex decision. So therefore we aim for business modeling which can help you in having a more integral decision support. Let me explain this with the next slide. As you see, we built some tooling within the AIMS modeling which helps you to have integral decision support. And as you can see, we brought in the character of the deep sea carriers, the inland terminal, the deep sea terminal. And by having this all in place and connected to each other via objects and constraints and variables, you can make integral decisions. For example, if the carrier starts with new trades or he changes his loops due to working together with other deep sea carriers, you will have new information available about the arrival of expected containers. But also his rules, a carrier has, where does he have his depots? What are his demurrage rules? Does he have also inland CY solutions within the hinterland? All things you can take in account. Secondly, at this moment there is a huge competition between the deep sea terminals. New terminals are opening in the Rotterdam, Antwerp and Hamburg area. So you see that volumes change because carriers choose for new terminal operators executing their handling. Also, with having the bigger vessels, the unloading time is also longer. So it's getting more important to know if your container is unloaded in the first shift, the second or the third shift, because that can already differ more than 16 hours in the availability of your container. And this 16 hours makes again possible to use another modality. Then you have the hinterland operators with barge and train. They have the timetables, the schedules, the capacity, but also of course there are delays, sometimes due to the weather or due to the water level, and then they will have also additional services or they offer alternatives, and it's important to communicate them with your other execution partners. What is also important, due to the high density of the inland terminals in the Benelux and Ruhrgebiet, you can also choose alternatives sometimes it's more attractive to unload your container in Duisburg instead of Venlo, and you can look to alternatives. Well, then of course there is also always the possibility to have trucking, which is relatively easy to decide, but even by choosing trucking you still don't know, for example, the traffic and the congestion. And secondly, all trucking companies, they have limited time for unloading and loading at a warehouse or a factory. So there, it can happen that you have additional cost by having a longer loading or unloading time. Also, the inland terminal itself has its characteristics with opening times, but also the availability having a depot or not for a carrier. And also the possibility for import and export matching. If you know that you can connect your container with an export customer, you can book a single trip instead of a round trip. All kind of information is needed. And last but not least is the character of the customer, because he knows exactly when he needs the container for import or export, and this date is very important for decision making, because when it is known he needs a container later, you have more time to choose alternative modalities. If you oversee this and you don't have any business logic in place, then you will have a quite heavy decision making in choosing the right carrier and also the right modality. And that's why we are wondering, are you able to take the right decisions in this way? And that's why we suggest to use business modeling and decision support. To summarize that, I've put in place this picture, which shows there is a network available in the hinterland. Above this network there are a lot of connections between ports and the inland terminals. These connections are executed by different operators for barging, for railing and for trucking. They have their schedules and of course also their rates. And by having this all in place, connected via a business model and having the right decision support rules in place, you enable your own planners but also management to take the right decisions on daily execution level but also on tactical level. Jan will show how this can work in practice via two cases, as already mentioned by Kim. First we have the single model planning customer case, and then we have the smart barging. So I hand over to Jan.
Good morning everybody. I will first tell something about a customer case. We did that DSV. DSV is a freight forwarder active all over the world, and they are the number 5 freight forwarder in the world, and recently they took over another branch partner, UTI, and they doubled their capacity. They have different activities which are in the field of road transportation, R&C, the container transport, and they have DSV solutions, mainly the warehousing operations. We have done our project at DSV R&C, where we have created a model to improve the possibilities to transport containers. Well, the challenge for DSV is always, if there's a new customer, new transport, they need to find out where in the network the contact is positioned and what possibilities there are to transport the container from the deep sea to the hinterland. And of course we have multiple carriers, over 30 in each deep sea port. There are more terminals where the deep sea carrier can land, and of course the connections to the hinterland, they depend on the deep sea carrier where the deep sea vessel lands. Of course, Walter just showed a photo about the complexity of the hinterland. Well, if at DSV we have different departments using this data, of course the sales department needs to know about the network and the possibilities to give good possibilities, to give good options to transport and to give a good price. The purchasing department needs to know where to purchase, because always it's important to know where have you got your big volumes. If you have large volumes around one terminal, you can have a good price, and if you have a goal to go to a certain location, a certain region, then you need to purchase for that region and make new possibilities there. And of course operation needs to use all this data to make their plan. And what you see is that you get all different kinds of documents, possibilities to combine data, and it's important for the planners to easily retrieve the data because they just have limited time and they have to solve a lot of transportation questions. The objectives for DSV is to reduce transport costs because they, of course, you can always take the most expensive, the quickest option, but it's also important to look at the question of the customer and to see how you can plan the container in an optimal way. And that aligns with the service to the customer. Of course, it's important to look at the environment to reduce your CO2 emissions, and also to increase your competitiveness by giving the good price and the good logistical solutions. What we've created for DSV is a solution where we have included all the data in one model. Here you see the network level. All the different connections in a network are available in the model, and it's possible to get all the data in different ways. You can either go to a location and see what possible transport options there are. So what you see here in the right side is the different options for a location, and in the left side you can select either a location of a customer or the inland terminal, and then you get all the related data from the location. The planner can easily retrieve data in the plan section. You see in the top section you can see the search options. So with a little number of data you can retrieve a lot of scenarios. You see here I've selected destination Venlo and the carrier China Shipping. You see the different prices in the contacted options. And if you see the contacted options on the left side or the right side, you see the different plan variables that you can use. Also, because of the network data that's in the system, you can also see possible alternatives that were not contracted yet. Also, there's a possibility to retrieve your bookings from the ERP system just by clicking one button, and then you get all the details from the containers, and you can use that for your plan. So the solution enables a planner to, well, within a minute to get all the different scenarios and to select one. You can either take the barge, the train, or the truck, but always you have to look at the different possibilities and the different questions from the customer. And what you see on the right side is you see the KPIs. So there you can see when you have to drop off the container, when you have to pick it up, what is the sales price, and what is your maximal margin. So yeah, you see the most important variables for your decision. Of course, if you have all the data available, then it's good to also be able to use it in your other systems. So we've also created a possibility to send a booking request, to retrieve the data from the application, combine it, and to send a booking request to either the terminal or either enter it in your ERP system, so that you don't have to use all this big data that you have in your back office and type it over. Of course, if you have all your data in a model, then you also can use the data to use it from different perspectives. The sales can use it to look at the locations in the hinterland where you are strongest, but also the purchasing department can compare the possibilities of the hinterland, see what has been done in the past, and combine those orders with the network knowledge and find optimal solutions for different locations where you want to go to. Of course, if you have the data available, it would be nice if you could also plan over deep sea, because we focused on the hinterland, but it's also possible to combine the deep sea. What you see here is an integral plan where we have combined the hinterland and the deep sea. So you see in the search section, you see the destination Venlo, and you see the deep sea destination Hong Kong. In this view, you see the combined optimal solution for deep sea and the hinterland. So actually the application looks at the different hinterland connections for the terminal where the carrier is sailing to, and then combines the tariff on the deep sea with the tariff in the hinterland and gives you the optimal solution. So in this case you see the carriers, you see the deep sea price, the inland price, and the total price. And then you can click it, and then you can see the modality that's available in this location. So actually I think this saves a certainly 30 minutes for a planner to make a plan, because all data is available and all data is actual, because it's all updated regularly. Actually, what we did is, if you have all data available, and if you only have a few variables to enter in the system, then it's also easy to go anywhere and have your data available everywhere. So what we've made is a little app where you can just have the few search variables that you need, type in some search questions, get some transport options, and then click further on and get the transport details, the plan details. And also at the end there is a button to make a booking or to make a booking request. So actually all this data that's available in Hinterland is all combined into a few simple screens and makes it very easy to make a plan on a very short notice without having to go through all the different terraces, contacting different people, and having all the knowledge about the network in your head. So actually in this model we've combined all the data that Walter just showed. We have the network in, we have all the terminals, all the connections, the carriers, the trucking and container information. We're combining it all so that you can just with a few search variables select all different scenarios and find your optimal scenario within a short notice. The result was that the DSV now has an possibility to optimize transport costs. So because now you can see all the alternatives that you have, you can make a choice of the best fitting scenario without missing one. Customer can be satisfied better because there's a better alignment with logistical concepts. Because sometimes you book a container on a very cheap carrier and then you have only 3 days in Hinterland to get your container to the customer and back. And if you look at the possibilities to use rail or barge, then mostly you have the container available for more days, like 10 days or maybe more. So then you can better align with the logistical concepts of your customer. And of course some customers just request clean transportation because they want to have it greener. So CO2 reduction, the result for DSV was that they made a model shift of 20% currently, and they think that by the end of the year 35% of the cargo will go by barge or by train, and they reduced the kilometers of the trucking by 96,000 kilometers, so quite some results, and it's also reduced the busy highways, business on the highways in Rotterdam. So the congestions in Rotterdam are now also reduced thanks to the single model planning tool. And all this resulted in a higher responsiveness and a higher competitiveness for DSV, because now they have all the data available to find the best scenario to fill in the need of the customer. Next step is also for me, it's about smart barging. So now we're looking at a smaller part of the logistic chain, where you have in the past you had the planning was very classical. The barges were in fixed loops, and everybody was sailing to Rotterdam to visit all the terminals in Rotterdam, and trying to be back in time to the customer in the hinterland to get the containers back. And if you see in Rotterdam, there's a lot of developments, because the vessels they visit different terminals, they switch from terminals, customers switch from container carrier. So there's a lot of dynamic, and there's a really need to fit the barge planning to the demand, because the demand is fluctuating also because of bigger vessels. If there was 2 vessels coming in on 2 days, now there's 1 bigger vessel coming in with all the cargo, and now you have to go to 1 terminal and take all the cargo with you. So you need to be able to dynamically plan your capacity on the different sailing ways, on different destinations. So the goal for the smart barging is to also to reduce the transportation costs, to have your barges as full as possible, to optimize this balance between the tonnage and the cargo, to meet the service levels, because always you have the appointments in the hinterland that you have to make, and then you have to also take into account the congestion in the different seaports, and of course to have a better service to the customers, to be sure that you're in time on the location where you need to be. And of course if a customer needs to have 5 calls a week in the hinterland, then you must look if you can use a smart barging solution to make these calls. Because it is a practice. You see one of the barges sailing through the port. They have to visit almost all the terminals to bring or to pick up containers. So, and if you see if you know about the congestions in Rotterdam, then you can spend 2 or 3 days in Rotterdam before you can get back. And if there's a big storm, then everything is messed up. And well, if you have to sail all the way back to Basel, then you need to have a lot of capacity to catch up these issues. I'm now going to give a live demo of the smart barging model. We've been analyzing barging solutions in the Hinterland for some years, mainly also looking at possibilities for hub and spoke. This resulted in some nice solutions in the Hinterland that are now currently active. This is the smart barging application. What you see here is what Walter just showed you in the pyramid, is that you have a network. So the network is the basis in the application. You see the connections, the different providers in the Hinterland, and you see also that you can use a fleet to service your customers. What you see here is the different vessels that you can possibly plan in the application. So either you can pick up bigger vessels or smaller vessels that you want to use in your scenario. For the calculation of the cost, we have made a relation between the vessels and also the fuel types and fuel costs. So fuel consumption for all scenarios is calculated based on the speed and based on the distances and based on the fuel type. What you see here is the terminals. So actually we have a lot of terminals in the current system. So we can actually sail all the way from the north of Holland to the south of to the north of Switzerland and to France. So we've included all terminals, and all terminals are connected in different ways in the network. We have a possibility here to use hubs so that you can drop off or pick up cargo on different terminals to improve your logistical plan. And here you see that we can include cargo. So if you have a scenario, of course the cargo has different profiles. It can be on a Monday that you have a lot of cargo in Rotterdam. It can be on a Friday that is only few cargo. And this can differ per period. Well, in this system we can import the cargo that's available. So we can import historical data to analyze the possibilities of the network. And here we can also shift cargo to other terminals or change demand. So say if we say, well, in Basel we have 10% more demand, then we can increase demand in the model. Then we can automatically calculate the effect on the network. If you look at the network, we have almost all terminals in the Hinterland connected. So we can in between terminals we can sail to Rotterdam and to Antwerp. And all connections you can easily see here. So here we can sail from Rotterdam all the way to Basel. And behind all those parts of the network, there's knowledge about the maximum speed, about the streaming factor. So if you're going upstream or downstream, it reduces speed or increases speed. Also, all the locks and bridges are in, so the system can calculate if you will fit under a bridge if the water is high, or if you can take all the cargo if the water is low. And all those calculations are behind it so that you can calculate a round trip from Basel all the way to Rotterdam. And once you get to Rotterdam, of course, there's a lot of possibilities to sail through the port, and that's why we have created port strategies. So here we have for Antwerp, we have east-west, so you can from the east to the west or from the west to the east define strategies. And you see the different port sections. So if we choose one of the strategies, then the model calculates the optimal possibility to sail through Antwerp, and also the same we have made for Rotterdam. We can make it also for other areas. Also, of course, there are structures in the application. So you see all the bridges on the way, and all the distances, everything is in the application. And also the waiting days and the opening days, because if you're sailing to the North of Holland and your schedule is not correct, then you can just get caught into one of the canals, and then your logistical plan will fail. Using all this data that's in the application, we can allocate vessels. So here you see the allocation of the vessels on this network. Actually, if I go to Antwerp, you see here the number of moves this vessel Alexandra is making here. Also the move time, because in the terminal we've also put in the move time. And underneath this port, we can also see the terminals that it's visiting in Antwerp. And you see, if we are in Antwerp, we see the cargo that is available for the different terminals in the hinterland. So you see at this terminal in Antwerp, we're loading for this terminal in Duisburg, we're loading this number of cargo. So all this cargo is in the back of this Gantt chart. On the other side, we also have the different stretches. So you can see the stretch. You can see there's some red marking, so this says that this lock is too small for this vessel, but I've overruled this rule because I know this vessel will fit in, because it's only a few centimeters. And also here you see that it's sailing at a certain speed. The actual speed is calculated, but I can also reduce or increase the speed to optimize my plan further. And you see the stretch that it's sailing on. So actually a lot of knowledge about the network, about the connections, about the services of the terminals is in the background of the application. And you can just easily plan a vessel just by creating like an initial plan where you can say what terminals you want to visit. So you can also make a dedicated service for one of the terminals or combine all the things. You see all the different ways to sail from Antwerp and to make this round trip. And you see the different strategies, and then you can create a plan, and then the application will create a plan taking into account all the different variables that are available in the hinterland. So this is a way to make one scenario, which you can make several scenarios and then compare the scenarios. You see, maybe it's a little detailed, you see the actual plan of this vessel where it's visiting, and you also see on what specific times the barge will be there and will depart, and also you will see how much cargo is loaded and unloaded. So actually you can verify if you have a good plan, because then you can see in practice if it's really in line with the plan you have. Then you can create different scenarios. So you can create a hub scenario or a hub scenario or just a point-point scenario. And you can compare the scenarios in the application. So in this case I've made two scenarios, one sailing from the hinterland to both Antwerp and Rotterdam, and one sailing dedicated to Rotterdam and dedicated to Antwerp. And here you can see the average speed is calculated, the number of barges planned. Also the calls, this is important for the service to the customer, that the customer has several connections to several possibilities to ship a container to the hinterland. You see the TEU that's transported, and it's calculating all the way down to the margin of the TU and the total cost. So here you can analyze different scenarios. You see here a scenario with 10 calls in the port, and you have 16. So depending on where you want to optimize, if you want to optimize your business or you want to optimize your cost, you can create different scenarios and then analyze them. And you see the enterprise-wide analysis. But you can also drill down. Like if you want to work together with different operators, then you want to have the overall overview, but also want to have the overview on barge level. So you see per barge, you see the revenues, you see the calls, etc. Then also you can drill down to the terminal, so you have a different perspective on the model, and you can see the results for the terminals, the revenues, the TU price, and all the way to service area where you can combine different terminals in the hinterland area and see the different pricing and capacity and revenue. So this way you can analyze different scenarios and see the effect of the selection of different scenarios. This is a short story that the smart barging tool. The experience we have with the analysis of the hinterland of the barging is that if you apply smart barging, if you use analysis tools, you can reduce transportation cost. Experience learned us that you can reduce the number of vessels you're using and increase the number of port calls just by smart barging. You can optimize the balance Also meet service levels by combining smart analysis tools with scenarios. And what I've seen, if you apply smart barging, you can have high competitiveness because you create a possibility to make more connections between the hinterland and deep sea, attracting more customers wanting to use your way of transportation and making it possible for you to grow bigger. Thank you. I give the word to Walter for the conclusion.
Well, yes, I'm back. I hope you have a good impression how you can deal with lots of data. I think both examples show that it is possible to analyze all the data available within the hinterland chain and to make the right decisions. And I think every day we are confronted with all the changes within the hinterland. I showed some on this picture some examples of the development. The delays in the port of Antwerp were discussed, but how can you react on that as a barge operator? The deep sea carriers, they continue to change their schedules, which also means that the loops visiting Rotterdam and Antwerp will be different. Export grows, that's a good sign, so that enables to have more import and export matching in the hinterland. But also still new terminals are arising, and also from time to time accidents happen which also have influence on the performance in the hinterland. So instead of having what I call the old way of working, that you concentrate on your own execution plan and hope you will survive sailing or railing into the port of Antwerp and Rotterdam, you can also try to use all this external information available by making a better plan and having more insight in the sensitivity of your own KPIs and improve your performance. So yeah, what we say, please look at your business, model your business, use external data and enable your planners to make faster and better decisions using the right business model. So if you have any questions, please feel free to ask them. We hope you enjoyed the webinar.
Well, thank you very much, Walter and both Art-Jan. I think it was very interesting, and I hope also for our audience, well, this provided some interesting examples and gave you some input to think about. I'd like to thank all of you for your time and signing up for this webinar, and well, we hope you enjoyed it. Again, a big thank you to Walter and Art-Jan of OVO for giving us a very informative webcast. If you have any questions, just feel free to contact us directly or visit the app OVO or the AIMS website to download any resources. So, well, thank you very much again. We will wish you a great rest of the day, and well, we hope to be in contact with you again soon. Bye-bye.